Okay, welcome back. I'm going to show you a video solution for problem 3, okay? In problem 3, I'm sure you all read the task. We are given with 10 grams of impure iron 2 salt, okay? Fe2 plus. It was dissolved in water and made up to 200 cubic centimeters, okay? Only 20 cubic centimeters out of 200 were taken and acidified with dilute sulfuric acid, and then it was and then 25 cubic centimeters of potassium manganate solution was added before the faint pink color appeared. So we need to understand what's going on in the solution, okay? The major point here is to write a balanced ionic equation for the reaction of acidified manganate ions, which is this, with iron 2 ions, okay? We know that the potassium manganate is a strong oxidizing agent. If it's an oxidizing agent, it should undergo reduction. And on the other side, iron 2 plus will undergo oxidation, okay? It will lose one electron and it will be oxidized to iron 3 plus. I can combine all that and let's see what I will get. So manganate ion aqueous reacting with iron 2 plus aqueous ions. I'm going to, for the purpose of speeding up the video, I'm going to omit the state symbols, but you have to show them in your calculations, okay? Now, so what I will end up, iron will be oxidized to iron 3 plus, and then the manganate will be reduced to Mn2 plus aqueous. Now, I have an overall ionic equation. Now I need to balance it, okay? And we know that it's in the acidic conditions because it was because iron was acidified, okay, with dilute sulfuric acid. So I can apply all the rules that we did cover in the lecture and balance this ionic equation now. First thing is to split them into two, MnO4 and Mn2 plus, and then the second one would be Fe2 plus, so oxidized to Fe3 plus. I can do this quickly by adding one electron here. All right, so that is done. Okay, next I have to work out this half cell equation, okay? MnO4 minus and manganese 2 plus. So first I have to balance manganese, but it's equal, so I don't have to balance it. Now next thing is to balance oxygen atoms, okay? I would introduce 4 water molecules on the product side, and I would add 4 protons then on the reactant side. Now I have to balance charges, plus 8 minus 1, that gives me plus 7, okay? And then on the product side is plus 2. Right, to make this plus 7 equal to plus 2, I need to add 5 electrons, okay? Plus 7 minus 5, that gives me plus 2. The number of electrons involved in the overall redox process should be equal, therefore I'd have to multiply this equation into 5 and then add both of them to give me the overall balanced ionic equation, which is required in this task, okay? So I would add 5 Fe2 plus 8 protons plus MnO4 manganate ion. I don't have to add electrons because I know that they will cancel, forming manganese ion, 4 water molecules plus 5 Fe3 plus, okay? That's the overall equation that is required. Now the next step, how many moles of iron 2, okay, Fe2 plus ions react with 1 mole of manganate ions, okay? We know from the balance, by looking at the balanced equation, okay, I can work out that 5 moles of Fe2 plus reacts with 1 mole of manganate ions. Okay. The next question: how many moles of Fe2 plus react with this amount of potassium manganate? Okay. So in order to answer to this question, I first have to calculate what the number of moles of manganate ion. Okay. And then by looking at the reaction stoichiometry, I can work out how many moles of Fe2 plus then react with this amount of moles of manganate ion. So number of moles of manganate, MnO4 minus, would be equal concentration times volume. Concentration is given 0.04 molar times the volume. I have to convert cubic centimeters to decimeters cube, and I will end up with 0.01 moles of manganate ions, and therefore the number of moles of Fe2 plus would be equal to 5 times of that. Okay, 0.01, that gives me 0.05 moles. Okay, now the next question: how many grams of Fe2 plus are there in 200 cubic centimeters of original solution, making sure that relative atomic mass of iron is 56. So first of all, I need to know how many moles were in 200 cubic centimeters. In order to do that, I know how many moles were in 20 cubic centimeters, okay, because I know that's the aliquot that was taken, okay, when it was reacted with this amount of manganate. Now I need to calculate what amount of moles were in 200. So if in 20 cubic centimeters I have this amount, then in 200 I would have number of moles of Fe2 plus in 200 cubic centimeters would be 10 times bigger than that, okay, because we were, yes, so that would give me 0.05 moles of Fe2 plus in original solution, okay, before diluting or before, and then the mass of iron would be what? Number of moles times molar mass, or in this particular case relative atomic mass. That would give me 0.05 times 56 grams per mole. That will give me 2.8 grams. Okay, and the final question is calculate the percentage by mass of iron in the impure iron 2 plus salt. Okay, in order to calculate the percentage by weight or by mass, molecular weight, I need to divide the mass of the pure mass or the mass of iron 2 plus, okay, over the total mass taken, okay, in impure sample times 100%. That would give me 28% of pure iron, okay, and the remaining 72% is the impurities, okay, contained in this iron salt.